Hey students, let me try another video solution that I got a question on. It's from chapter 28, it's number 28, and it has to do with, again, relative velocities. And so let me encourage you, if you have not already watched my video on help between figuring out the different speeds. In fact, I'll flash this up here. I did this earlier this morning here, and I did this whole idea of what is the U prime and the V, and I finished the video with a comment about perhaps there are some helpful hints on what might make it the easiest to solve this problem. Anyways, I'm going to use that information in that video to answer this one. So let's start here. It says, when a missile is shot from one spaceship towards another, it leaves the first ship at 0.95 C and approaches the other at 0.7 C. All right, so maybe I'll put a spaceship right here. Maybe I'll call this number 1. And it says the missile is shot, and so there's some kind of missile heading out. Okay, and it says the speed is 0.95 C. Now, we have to read a little bit into this problem for it to make any sense here, because it says it leaves the first at. And so what they mean here, I'm pretty sure, is how fast is it leaving this, how fast is the missile leaving the ship as measured from this first ship? Okay. They don't say that explicitly, but I'm pretty sure that's implied here. It leaves the first at 0.95. It approaches another ship, so there's another ship. And notice that this number here, 0.75, is lower than that one. So that would tell me that this ship is in the process of moving away from that ship. So there's some speed relative between the first and second ship, and it's got to be moving away to get a lower speed. And that kind of makes sense to the problem. I mean, it sounds like the first spaceship is trying to shoot down the second spaceship. Okay. But anyways, there's this gap being closed here of 0.75 C. Okay. And maybe I should put a little parentheses here. I like to do this because now I have my 3 different speeds. And this is the U, the U prime, and the V, the 3 speeds involved in a particular problem. Now, again, I'm going to reference that video I said that you could pick the one that is quote-unquote stationary. That is the one that is your reference to be any object, any of the 3. And you can also take your object that you're viewing as any of them, and your observer as the other 2. Now, I think naturally when you look at this, you would say that the missile is the object, and the 2 spaceships are the observer. And let me do that here and say, okay, then these will be my 2 observers. And maybe I'll take observer number 1 as me kind of being in there. I referred this to as the reference observer. So this is the non-reference observer, and this is the object. And to me, that kind of seems like the natural approach, so I'll do that. Let's see. So this U would be the speed of the object as seen by the reference. Okay, so this would be 0.95 C and a plus because it's moving to the right. So that's the missile there. The U prime would be the rate at which the object, the missile, is closing in on the non-observer, and again, it's to the right, the mover, so it'd be a plus 0.75 C. And then the V is the speed of these 2, which is not given in the problem, but that is the question. What is the relative velocity of the 2 ships? So this is the unknown. And so if we use the equation U equals V plus U prime over 1 plus V U prime C squared, we can put in the two we know, the u and the u prime, and solve for the v. And that would work fine. It would just take quite a bit of algebra. And nothing wrong with that. In fact, maybe I'll do that at the end. But I thought this might be a good opportunity, again, as I said at the end of that video, is maybe you ought to switch it up. Okay, so I'm going to draw a line here and say, all right, what if I did this? I'm looking for, this is the ultimate question, what is the relative velocity of the two ships? So maybe I'll change colors here. What if I called ship number 2 the object and keep ship number 1 as the reference? So what that would mean then is I am looking for the u, right? The u is the speed of the object as seen from the reference. And this equation is set up perfect for that. Of course, what that would mean then is the missile would have to be the non-referenced observer. And so in that scenario, I'll call it green, I'm looking for the u. The u prime then is the velocity of the object from the non-reference. So from the non-reference, you would, this gap would be closing. It would kind of be viewed as the object is moving towards it, so it would be a negative. And it would be closing this gap of 0.75 c. So kind of a different way of looking at it, instead of this way and having some harder mathematics, is to look at it this way, where I'm looking for the easy one mathematically, and then I've got to maybe conceptually say, what would the u prime be? And then, of course, the v would be the velocity between the two observers. And again, as seen by the reference one. And so this second observer is moving to the right, so plus, at 0.95 c. So based on that logic, my math becomes a lot simpler. I'm looking for u, and it becomes the v, which is 0.95 c. added to the u prime, which is negative 0.75 c, all over 1 plus, and again, here's the 0.95 c, and multiplied by the u prime, which is the negative 0.75 c, all over c squared, which, when you put these two together, you get 0.2 c. And then this one is nice because the c's cancel off. Then you get a little negative, so 1 minus something, 1 minus. I'm grabbing a calculator here. I would have 0.95 times 0.75. So that's 0.7125. And so let me go 1 minus that last answer. So down in the bottom would be 0.28. So we've got 0.2 in the numerator divided by this 2875. And I get a speed of 0.69. What is the relative speed? So by this method, viewing this as the reference, we're saying this one is moving here away at 0.95 c. Okay? And it makes sense. Remember we said earlier, it's got to be moving away, it's got to be going faster here, closing the gap if you will. Now, if you want, we could go back to what I think conceptually might be easier, but mathematically harder here. So I'll switch back to my red. If we do what we did earlier, we could say, well, this is 0.95 C here for the U. The V is the unknown. The U prime is 0.75 C. And then we have 1 plus. And then right here, we get the V, which is, again, that unknown. And the U prime is 0.75 C all over C squared. And one of the C's will cancel off. And so we'll have 0.95 C here. We'll get a V plus 75 C here. And this one would be a 1 plus 0.75 V over C. You know, I'm going to need another piece of paper for this mathematics here. But maybe the thing to do then is to take the 0.95 C and then bring this to the other side. 1 plus 0.75 V over C equals V plus 0.75 C. When I distribute this becomes 0.95 C plus, and you can get the two C's to cancel, and we'll be left with a V. And we'll be 0.95 times 0.75. And so that's the 7125. We've got a V, and we got 0.75 C. When we move this over to here, it'll become a minus, so that becomes 0.2 C. And then when we subtract, or we'll leave that V alone, but we bring this over, minus 0.75125 V. And so 1 minus that last answer is 0.28775 V, 0.2 C. And then the final step would be the 0.2 C over 0.2875, which was the same math we got before, but 0.2 divided by that last answer, and we are at 0.695 C. Yay! And so, like I said, this is a good illustration that you might take the conceptually easier one and then longer mathematics, or shorter mathematics, but maybe a little bit harder conceptually in the green here, where you're looking at the observer. Your choice. But in either case, you should come up with the same answer, and that is that this ship here is going faster and going away at almost 70% the speed of light. All right. Hope that helps. Bye now.